Hey folks, thank you so much for dropping by. I'm Steve the Math Buddha, and I'm on a mission to make math simple. I love to find simple solutions to seemingly complex problems. And today I'm going to show you a really simple way to solve cost mixture problems. Now, a cost mixture problem is not the same thing as a solution mixture problem. I know that when I Google mixture problems, I see a lot of solution mixture problems. And you know what? I have a really fun way to solve those too. So please look for that video to come out in the upcoming weeks. But today I'm going to be showing you cost mixture problems. So what is a cost mixture problem? Well, what do you know? We got one right here. A cost mixture problem is a problem that looks very much like this problem on the whiteboard behind me, where we have two types of a particular product, in this case cashews and peanuts, and the unit costs are different. We've got $2.50 per pound for cashews and $2.25 per pound for peanuts. Now we're told that a mixture is purchased, and we're told the weight and the cost of that mixture. And now we have to back into the individual weights. How many pounds of cashews were purchased and how many pounds of peanuts were purchased. Now I would imagine that many of you have seen this problem before. I know that it was a common problem back when I was in high school. And if you've seen this problem, you have probably seen an algebraic solution to this problem. So what if I told you that you don't need any algebra whatsoever to solve this problem? Well, you'd probably say, yeah, we know. We saw that in the title of your video. Let's get on with it. Let's see this amazing solution. And yes, in a few minutes, I'm going to show you a solution to this problem that requires only arithmetic. But before I do want to show you the algebraic solution. Now, if you have already seen the algebraic solution, please feel free to skip on to the non-algebraic solution. But if you have not seen the algebraic solution, then maybe you want to hang on for a few minutes and see how it works. Because you know what? In an algebra class, you would have to solve this algebraically, as you would on an Algebra Regents. Now, I am going to go through this algebraic solution pretty quickly because I really do want to get to the fun stuff. But if any of you want to see a more detailed step-by-step explanation of the algebraic solution, please let me know in the comments because I can do a video on anything you all want to see. And with that, let's take a look at the algebraic solution. For the algebraic solution, we always start with this table. The weight times unit cost equal total cost table. Or pounds times dollars per pound equals total dollars. Now, a lot of the information that goes into this table comes straight out of the problem. We're told the unit costs of the individual nuts, and we're also told the information for the mixture. And that information goes into the table right here. Now, the next thing we have to do is we have to put in our variables. The variables go in our weights column. Now, to get the total cost, we multiply. Pounds times dollars per pound equals total dollars. Now, the unit cost for the overall mixture we don't use. So we put an NA. That's for not applicable. Now, our equations come straight from the columns. We have an equation for weight, and we have an equation for cost. So we have our two equations and our two unknowns. We should be able to find a unique solution, as long as the equations aren't multiples of each other, which these equations are not. And by the way, I'm going to be doing a video on this subject of how do you determine when a system of equations has a unique solution. That's going to be part of my frequently asked SAT questions series. So please look for that video to come out in the upcoming weeks. So how do we solve? Well, the first thing we do is we multiply the first equation by 2.25 to get our third equation. Now, when we compare the third equation to the second equation, we see that the coefficient of P is the same, but the coefficients of C are different. So if we now subtract the third equation from the second equation, we're going to get a single equation with a single unknown. And that should be easy to solve. We just divide both sides by the coefficient of C, which is 0.25, and that gives us our desired C equals 2. Now, we still have to solve for P. In order to solve for P, we have to plug C equals 2 into our first equation, which gives us 2 plus P equals 10, or P equals 8. And what does that mean? Well, what are C and P? C and P are our pounds of cashews and our pounds of peanuts. So that gives us 2 pounds of cashews and 8 pounds of peanuts. So that's our algebraic solution. And you know what? There's nothing wrong with the algebraic solution. Like I said, in an algebra class, you would have to solve it this way. But this is not an algebra class. And in this video, we can solve this problem any way we'd like. So let's move on to the new and improved solution. Now, if you're liking the video so far, please click that like button and please share on social media. And hey, let's turn on those notifications so you'll know when my videos come out. And please, please don't forget to subscribe. And by the way, let me know in the comments, what do you guys think of the Math Buddha t-shirt? The design for this t-shirt was created by this amazing artist that I found on Fiverr, and then I had it printed on Zazzle. One of the things that I really like about Zazzle is that you don't have to create a seller's account in order to print your design. You can print any design you'd like on pretty much any product they have. You could literally upload a picture of your cat and have it placed on the mug of your choice. A couple of weeks later, you'll get that mug with a picture of your cat on it. I have links to both sites, my artist's Fiverr page, and also the website, the Zazzle website, where I had this t-shirt printed. And if you're going to buy anything on either one of those sites, it'd be great if you used one of my links because it helps to support this channel. And with that, the solution that we've all been waiting for. Let's suppose there's a sale on cashews, 25 cents off per pound. So how much do cashews cost now? Well, the original cost was $2.50 per pound, and we're saving 25 cents per pound, so the discounted cost would be $2.25 per pound. So what does that mean? That means cashews cost the same as peanuts. If that's the case, it should be easy to figure out the cost of the 10-pound mixture. We just multiply. 10 pounds times $2.25 per pound equals $22.50. So how much did we save? Well, if the original cost was $23 and our discounted cost is $22.50, then our total savings is going to be $23 minus $22.50 equals 50 cents. So if our total savings is 50 cents and we save 25 cents on each pound of cashews, we must have purchased 50 cents off divided by 25 cents off per pound of cashews equals 2 pounds of cashews. Which means how many pounds of peanuts? Well, the mixture is 10 pounds, and we purchased 2 pounds of cashews, so we must have purchased 10 pounds minus 2 pounds of cashews equals 8 pounds of peanuts. Now, the interesting thing is we did the same calculation when we did the algebraic solution. If you recall, when we did the algebraic solution, we also subtracted 2250 from 23 to get 0.50. The difference was when we did the algebraic solution, we had to bring in all this algebraic information in order to determine that this 0.50 is equal to 0.25c. What we did here was we organized the information a little differently. This $22.50, that's our discounted cost. Now, if that's our discounted cost, and we know that we're saving only on cashews, then we know that we can get our pounds of cashews by dividing our 0.50 by our 0.25. And we can figure that out without carrying around and manipulating two algebraic equations. So that's my solution. Let me know in the comments. Did you like my solution? What did you like? What didn't you like? What could I do differently? Do you like the homemade look? Do you like the whiteboard and the magic marker? I really do want to learn how to bring the text in digitally. I want to learn everything. I've learned so much already. I have done so much work editing this video, and there's so much more I know that I can learn. And I have a vision for where this channel can go, and I'm really excited about it. It's going to be a wild ride, and I truly hope that you all come along and join me. So this is the Math Buddha signing off. Have a great night, and have a truly pleasant tomorrow. It's done. I can't believe I finally finished my first video. Before I go, I wanted to leave you with one final challenge. There's some text on the whiteboard that's not actually on the whiteboard. I left it off the whiteboard when I was filming, and then I brought it in during the editing process. Do you see what I'm talking about? Was it obvious? If not, take another look and see if you can find it. I will let you know next week when my next video drops exactly what I'm talking about. Until then, have yourselves a really amazing week. This is the Math Buddha signing off once again.